Okay, in the previous chapter we were talking about the direct force. For example, if we think that this is an object and this person is trying to move this object, so this is, which types of force is this one? This is called a direct force, or the force which may affect directly on an object and causing the object to move in a straight line. Okay, so in the previous chapter we were talking about this one. Right now we are talking about completely different titles. For example, this force may cause this object to move around the central line. Okay, so in this chapter we will talk about these types of force. It is not the force that which causes the object to move in a straight line. It causes about on the object to move around a circle or rotate it. Now see here the first part. Okay, here we have a door. This is a door, and let me to explain point by point. Okay, so here this is the frame of a door, the frame. Okay, so we usually in daily basis we do what? We apply the force at the specific point. For example, here is the position that we are applying the force, and this force is called what? The push or pull acting on the object. So for example, if you want to open the door, so you do what? You push the door, then the door will be open. Then if you want to close the door, so you apply the force but you pull the door to be closed. We will talk about the effect of this force. Okay, and next one we will come to here, the distance. For example, here we have what? This exactly the point that which joins the door with what? With the frame. It is called pivot, the fixed point around which an object turns. Okay, so of course that this door will turn around these points. These 2 points, these 3 points are called what? Pivot, the fixed point with the object may move around that one. Okay, but here we have distance. Distance is the specific part from the pivot to the points that we are doing what? We are applying the force. Here from this point till this point. Okay, so this is called what? Distance. So this distance. Okay, what is the next very important point? And if you want to explain all these three factors, which is pivot, which is distance, and which is force, and if we apply the force, so of course that the object may do what? Move, but not directly around the specific point. So this movement is called what? Moment. Now let's talk about moment. What is moment? Here is the main point of our discussion in this chapter. Okay, so here is the definition. The result, okay, the resulting turning effect created by the force. Okay, so the force which we are applying to create a what? A turning or a circle motion or orbiting is called what? Moment. So what is the meaning of moment? Meaning of moment, but not in physics. Okay, in daily basis, what does it mean? What do we use for moment? Okay, for example, when your friend is calling you, so you can say that just give me a moment, wait a minute, or wait a moment. So what is the meaning of moment?
Time.
Yes, time. Yes, that's exactly. Okay, so in daily basis, when we talk about the moment means a short time, a very short time, or the current situation. For example, I am speaking at the moment. Right now I am speaking. 1 moment means a very short time. Okay, it is equal to about second or minute. 1 moment means one specific short time. But what does it mean in physics? In physics, moment means that the object which is moving around a specific point. So this is called moment, or the resulting turning effect created by a force. Okay, or we apply the force to make an object move around a specific point is called what? Moment. But moment is completely different than momentum. Here is. Okay, so first, as you can see, that momentum is the effect of turning this door around this fixed point. Okay, now come to here. What do you think that which types of formula do we have if we want to find the moment? Based on this definition, for example, here we have force, and then we will have distance. For example, if we put the name of distance with d, okay, and the force with F, and momentum with m. Okay, so which types of relationship would you suggest between momentum, force, among the momentum, force, and distance? Can you guess any types of relationship? Okay, so in the previous lesson when we were talking about momentum, P, momentum was equal to mass times velocity. Okay, so what is your suggestion if you want to count, for example, moment? Which types of formula will we have about the distance and the force?
Sir, I think D should be multiplied by F or vice versa. So M
F
equals to
times D.
D.
Yeah, this is exactly the formula of what? Moment. Moment means that multiplication of F by distance, or distance times force. Okay, so this is exactly the formula of moment. Moment will be counted as per this one. So moment, which types of unit will we have? Force will be counted as per what? What is the unit of force?
Newton, sir?
Yes, Newton. And what is the unit of distance?
Meter?
Meter, yes. Okay, so in as MKS system, in MKS system, or SI system, yeah, in SI MKS system we usually use this unit for momentum. Okay, now let's come to here. Yeah, this is exactly the formula that you said. See here, if we put the name of M for momentum is equal to what? Force multiplied by distance d. This is the unit. Okay, so we can use the unit of force is Newton and unit of distance is meter. So what will be the unit of moment? Moment will be Newton meter. So this is exactly the formula that we are going to use in the momentum. And next one here we have different types of examples. Okay, so let's count. After that let's find the momentum or moment of these objects. For example, here we have a spanner. Spanner means that a can opener. Okay, so the can opener, for example, the distance, this is a bottle, this is a bottle, and the distance between the force that you are going to apply and the for example the bottle is how much? For example, 1 meter. So here we have distance is 1 meter, and how much is the force that we are going to apply? It is 100 newtons. So let's find moment. Okay, moment, let me write with capital M here. Moment is equal to distance times force. Okay, so moment is equal to 1 times 100. So finally you will have what? 100 Newton meter. Okay, so this is about the first one, can opener. Okay, so let's come to the second question. And this question, for example, you are having a wrench. Okay, so you are going to open a nut and see that we are having here 25 newtons. Okay, so the force will be 25 newtons. And then how much is the distance? Distance is 4 meters. And now let's count moment. Moment is equal to distance times force. Let's do apply the values. We are having 4 meters distance, and then times force is 25 newtons. 25 newtons. So what will be the result? Then we will have moment will be equal to 25 times 4, we will have 100 newton meter. So this is the moment of the second question. Now let's come to the third question. And the third question, we are having force F is equal to how much? 15 newtons. 15 newtons. How much is the distance? Distance is 2 meters. Okay, so let's do count. Moment is equal to distance times force. Then how much will be the momentum? Momentum will be 50 newtons time 2 newtons 2 meters, sorry. Then momentum will be equal to 50 times 2 will be 100 newton meter. Okay, now come to the fourth question. In the fourth question, it is also screw bar. This is also can opener. Next one, here we have how much force do we have? Force is equal to 10 newtons. Okay, 10 newtons. And how much is the distance? Distance is 10 meters. So let's do count the momentum. Momentum is equal to distance times F. Okay, so momentum is equal to 10 meter is the distance times we have 10 newtons. So the result will be momentum will be equal to 100 newtons newton meter. Okay, so if I ask you one question, we have the same momentum, but we have different distance and different forces. Okay, so if you want to bring changes in the force, which changes you should bring in the distance, or which types of relationship does the distance have with the moment? Okay, if you are
Is
having,
it done,
yes,
sir?
yeah, you may continue.
I see it like, is it a direct relationship?
Yes, it is direct relationship or proportional relationship. It means that by increasing the distance, we will have more what? More momentum. But what about the relationship between the force and the distance? If we have the same moment, now see, check the examples number 1, number 2, number 3, and number 4. By increasing the amount of distance, which types of changes came into the force? For example, in question number 1, we have 1 meter and we have 100 newtons. But come to directly in question number 2. Now see that in question number 2 we increase the amount of distance to 4 meters. But now see that the amount of force increased or decreased?
It's decreasing.
Yeah, so that's why they are having indirect relationship. For example, by increasing the distance, we need to decrease the force. Okay, decreasing the force, and we can increase with the distance. And the same come to question number 3. In question number 3, we have increased from 1 meter to 2 meters. Then the force decreased from 100 to 50. And in question number 4, the same. In question number 4, for example, in the question number 1 we had 1 meter. Now here in question number 4 we have 10 meters. Okay, so in 10 meters, when we increase the amount of distance, so the amount of force decreased, and they are having opposite relationship or indirect, but both of them are having direct relationship with the moment. Okay, by increasing the force, moment also will increase. By increasing the distance, the moment will also increase the same. Now come to the let's come to this next slide. Okay, but here we have one exception. Okay, here we have one very important exception. See here, you may read the title. The angle of applied force drastically alter the effect turning distance. Okay, but how to apply the force to increase the maximum effect of that force? Okay, so this is the very important. Maximum distance is equal to what? Maximum turning effects. Here is the first condition. Your force always must be what? Here we have an English word that's called perpendicular. Perpendicular. What is the meaning of perpendicular? Perpendicular means that when you apply the force, that the angle that the force will produce, it must be 90 degrees. 90 degrees. Not less, not more. For example, if you apply the force with or under the specific angle, and the effect of this force will be decreased. But what will happen if you apply, for example, directly to the exact direction of the object? So even that the effect of the for example, the force will be equal to how much? Will be equal to the 0. This is the case. Okay, now let me draw here. Let me draw one graph for you, then let me explain here. For example, this is the door. Okay, so this is the door. Let me draw with different colors. Okay, so here is the handle of the door. Okay, so here it is the pivot, means the fixed point that join the door with the frame. Okay, now here we have I wanna draw 3 vectors. Okay, so this is the first vector, which is producing 90 degrees here, 90 degrees. But sometimes we may force, for example, with the different angles. For example, this may produce with the door 45 degrees. Okay, but if you are applying this force and there is no angle, it is directly pushing the door toward this one. So if we put the name of F1, F2 and F3. Okay, so you may check which one is the most effective force that can be easily open the door, can close the door, and we will have the highest amount of what? The highest amount of moment.
F2, sir.
F2 with the 45
F1,
degrees.
sir.
F1 is 90
Five,
degrees.
sir. I thought it is 90 degrees because it was in the crossing point.
So this one, F2 will be applied with the 45 degrees. Okay, but F1 is with 90 degrees. 90 degrees. And F3 there will be for example, directly applying on the this one on the axis of the door, but we do not have any angle. This one, the angle will be 0. Okay, which one is the most effective?
F1, sir.
F1. Why? Because whenever we want to apply first, the first F must be always applied 90 degrees. 90 degrees, or we can say that perpendicular on the axis of motion. This point is very important. Okay, so if you want to use your force effectively, the force that you are going to apply must be 90 degrees, and 90 degrees on what? On the axis of the force, the object which is moving on that one. This is the most important point. And let's come back to here. Okay, for example, if you want this object to move ups and downs, if you apply the force perpendicularly, then the object will move easily. But if you apply at this, for example, under the specific angle, so first we have a specific rule in physics, then we should divide this force. For example, some of this force may affect in this direction, but some points of this force may direct effect in this direction. Okay, so your force will be divided. Only this force, okay, this force will affect on the moving this direction, but the next one is not. Now see that now you want this object, for example this part, to move ups or downs. Okay, but you're applying the force here. Will this force be effective to make the object move ups and downs? The third one.
No, sir.
No, sir.
Why? Because see that there will be, the angle will be 0. Okay, so this directly moving this one, so this direction, so it cannot help the object to move ups and downs. Okay, so in moment we have 3 important points. First, the force must be applied under the 90 degrees, and next one, if you apply, for example, under the specific angle, so the force will be decreased. And if you apply the force under the 0 angle or 0 distance, so the force will be, the effect of the force will be equal to 0. Okay, so here we have one very so here, yeah, it depends, for example, in which direction you are applying the force. Okay, and if in the questions, if you see that you are having what? Clockwise moment, it means that the direction of the force is equal to the direction of what? Clock. Okay, now see that if we think that the clock is moving from up to down, from left to right, okay, but if the force is applying to move the object from the opposite of the, for example, the clock's motion, so this is called what? Anti-clockwise. So in circular motion we have these two vocabulary, these two words are very important. Okay, so they are exactly explaining what is the direction of this motion, clockwise and anti-clockwise, so you may keep in your mind always. Here we have just 5 minutes. Now here we have one example. One example is here. Actually this door is not matching with the exact definition that we are having on the question, so let me bring some changes to this one. Next one, let me to bring some changes to this part of the question. For example, this let me write here. Okay, see, let's read the question. Look again at figure 2.5. Okay, person A pushes the door with the force of 20 newtons at the distance of for example 20 centimeter from the hinge, okay, the pivot. Now see that this is the person, so you may think that this person is moving the door from here, from this point. Okay, so this is person A, and person A is taking the door, not letting the door to be open. Okay, so this lady is very angry and she is not going to let the person to open the door. He is going to escape, but she is not letting this on. Okay, so she is forcing how much force? The force will be 200 newtons, but how much is the distance from pivot, okay, till the point that it's acting, the distance will be 20 centimeter. Now come to the second person, okay? Next one, person B opens the door by pulling the door handle, and which is 80 centimeter. Okay, so here is the door's handle, here is the door's handle, and he is forcing the door with the force is not clear, but how much is the distance from the pivot from this point? It is 80 centimeter. Okay, so person B for example opens the door by pulling the door handle, which is 80 centimeter from the hands. And what is the momentum pulling force that persons for example the person B must use to open the door? Okay, so here is the simplification sketch of the problem. And here also you can find, for example, this is the pivot, and this is the distance that the person A is using, and this is the distance that the person B is using, and the force is not clear, the force is unknown. And here we have the force of the second person, the force of the first person is 200 meters, okay, 200 newtons and with 20 centimeter. Okay, so how to solve this question? Or how much force that this person should apply to open the door? Okay, so do you have any other class after this period, or should I should stop here?
Yes, sir, we have math.